Antonio and Eric, please take the show from now on.
All right. Great. Thanks very much. So I'm Eric D'Andrea. I'm here with Antonio, and I'm not even going to attempt to say it. So when we get to your slide, I'll just let you pronounce it because I'm not gonna go down that road. So if go to the next slide, please.
Oh,
you're driving.
Yep.
Yeah, you're the driver. You're in the driver's seat right now. So for those who don't know who I am, I'm Eric D'Andrea. I work for Red Hat. I've been doing software development for 20 some odd years, mostly in financial services, insurance, and whatnot. I've been in the open source world for a long time. I'm a current contributor to Quarkus. I've contributed to Spring a lot in Spring Security back in the day. I build training programs. I've written a book, and that's about me. You can find my Twitter handles and LinkedIn and all that kind of stuff over there.
Well, my name is Antonio Goncalves, and as Bruno said, I'm from Microsoft. I'm a principal software engineer at Microsoft, even if I have this Quarkus jacket. But why do I have this jacket? Because I've been, developing for many, many years, and most of it in Java EE. I follow the entire J2EE and Java EE and Jakarta EE thing. And in terms of runtime, same thing, WebLogic. I used to be a BEA system developer. And through all this history, here I am contributing on Quarkus. And like Eric, I wrote a few books, a couple on Quarkus actually. And I also talk at conferences, mostly about Java, Quarkus, and recently cloud stuff around Azure.
All right, so we got 25 minutes. I think we've actually got a little bit less than 25 minutes now. So get ready to get your face wet, because we're going to throw a ton of information at you in a short period of time here. So really, we're going to start off by doing a demo. We're going to talk about the Quarkus Superheroes, what they're all about, and how they work. And Antonio's going to talk about some Azure goodies behind the scenes of what we're doing here. I think it's some new stuff that a lot of people aren't quite using yet.
Exactly. So
off we go.
Off we go.
To save the day. So here's the system. So the application that we're going to describe is a system for being able to pick superheroes and supervillains, and you can pit them against one another. And there's some super secret algorithm behind determining the winner. The joke is if you can go find the code and tell me what the algorithm is, we'll give you some kudos on Twitter. But that being said, it shows you the who wins, who loses in real time. And then on the left side there, you've got this record keeping application, which is watching what's going on and keeping track of kind of keeping them as teams of heroes and villains, which team has won the most battles, and then computing the top 10 winners and who's won the most there. So it's pretty simple. It's easy to demo. It's easy to show, but as you'll see, there's a whole bunch of stuff behind the scenes that we're going to talk about here.
Well, wait, because there's more villains winning. I'm trying to make the superheroes win. Anyway, so let's go under the cape. Let's talk about the architecture of this system. As you can see, if you are a web developer, you could have easily done that with HTML, CSS, and jQuery. But because we are backend developers, we made it slightly more complex. But there's also a reason. Each time you talk about a technology such as Quarkus, you always throw a bunch of Hello World samples, Hello World on how to access a database, Hello World on how to have a REST API. This sample is way more complex. It's a bunch of microservices. I will explain it. And it's complex in terms of code, in terms of architecture, but it's also a nice way to learn because there's documentation on this application. It's fully automated CI/CD, so the tests run. It's you can deploy it with Docker Compose or Minikube. So it's an nice application when you want to learn more about Quarkus and bring a higher level of complexity. So no, it's not jQuery. First of all, the UI. So the UI is a separate application, a SPA, single page application, written in Angular. It could have been another framework. What's important is the UI it talks to a microservice developed in Quarkus, of course, called the Fight microservice. So the Fight is the entry point of the UI. When we click on new fighters, the UI invokes the Fight microservice to get a new villain and a new hero. How does this work? Well, the Fight microservice actually talks to other microservices. The hero microservice is another one written in Quarkus 2 with a Postgre database. So on its own database, there's all the lists of the superheroes with the image, with the bio, and the magic number here will tell, with the power of the superhero. Same for the supervillain. So there's another microservice with its own Postgre DB, and that will give you return a random villain. So each time you click on new fighters, it invokes the Fight microservice, which invokes the hero and the villain microservice. Then when we want to fight, we click on the Fight button. And again, we invoke the Fight microservice. Like Eric said, it has a funny algorithm, take the superpower, does a bit of magic, and that's the microservice that will compute and will let you know who is the winner and who is the loser. And we call that a fight. And a fight between a villain and a hero will be stored on a Cosmo DB. And if you look at the list underneath, that's actually a query on the Cosmo DB database. And once we have this fight, we also send it to a Kafka stream. So there is a message defining who is the winner and who is the loser, if it's a villain or if it's a hero. And on the other side of this Kafka stream, we have another microservice with its own UI, the statistic microservice that refreshes itself thanks to WebSockets. Each time it listens to the Kafka channel, it computes the top winner and returns and displays, the statistics. So all that is written in Quarkus. So maybe Eric, you could tell us a few words on Quarkus.
Yeah, so I know we don't have a whole lot of time, and so if we talk about hey, we're riding up in an elevator here, what can I tell you about it? Because we don't have a lot of time. 2 minutes doesn't quite do it justice. So if we move to the next slide, Quarkus is essentially a stack to build distributed systems. And if that word distributed systems wasn't there, you'd probably think I was going to say microservices, right? But Quarkus focuses more on just microservice. It contains all the pieces and building blocks you need to build pretty much any type of application you can envision. So, a full stack framework using all or most of the technologies that you are probably already using, things like GPA, Hibernate, JTA, JAX-RS, Liquid-Base, GraphQL, Vertex, gRPC, Kafka, all that kind of stuff is already there and already part of the platform. It's also based on a container first philosophy, meaning that it tailors the application for GraalVM and the hotspot JVM. So you're boasting really fast boot times, really small RSS memory usage, and pretty near instant scale up and scale down with really easy and no hassle native image generation. That can really shrink your application to things to be much smaller and much faster on the JVM. And GraalVM really loves the code that you write with Quarkus, because Quarkus tailors and makes GraalVM understand what it is without the user really having to think about it. So, furthermore, combining imperative and reactive, Quarkus doesn't really care which paradigm you write in. You mix and match within the same class, even if you want to, and it'll just kind of figure out what it needs to do from a threading model. Kubernetes native, so the combination of Quarkus with Kubernetes, being able to deploy and run and all the tooling around doing that, it makes Quarkus really, really good. But something people don't touch on a whole lot is what we call developer joy. So things like, hey, I wrote my code and I want to see it refresh up to date immediately without me having to bounce my JVM, or be able to spin up other downstream services. In our examples here, we're talking about using databases and Kafka and MongoDB and all that kind of stuff. I shouldn't have, as a developer, I shouldn't have to care about what those services are or where they are. If I'm doing local development on my machine here, they should just be provided for me, and Quarkus will do that for me. A fan like me, I'm very into test-driven development. So, being able to write my tests, write my code, and have the framework understand the relationships between my code and my tests. So.
Okay, so what about deploying this entire architecture? So we mentioned those microservices, and Eric talked about the containerization, and that's also the beauty of Quarkus. It's really, it's out of the box. You can easily create a Docker image when you create a Quarkus Bootstrap. So everything here has been containerized. So even the UI, the fight microservice, the villain, the hero, and the statistic. Then, so that's for our business code. Then to deploy all these containers in Azure, we will see what we will be using. But it's important to stress out that we've deployed our code in containers, but we've used all the managed Azure services like the Postgre or the Cosmos DB for MongoDB, or Azure Event Hub for Kafka. So the demo that you saw, it's our code deployed in containers, but using all the Azure services.
I mentioned too, we use the native image version. There's images for JVM and for native, and we are using the native ones.
Yeah, we will give you the URL of our repo, and you will see that for each microservice, we've packaged it in using Java 11 and 17 and native or JVM. So in this demo, we deployed the native one. So Jason was mentioning app services, earlier. In Azure, we also have AKS, so it's a Kubernetes platform, but we've used Azure Container Apps, which is the new kid on the block, because, as we said, it's very easy to create a container out of a Quarkus application. But once you have all these containers, how do you deploy them? And some people will say, well, Minikube or Kubernetes or other frameworks like that. So it's quite complex when you are a developer. You don't want maybe you don't want to go to the Kubernetes world. So Azure Container Apps, it's actually a good one. It's a fully managed Kubernetes platform. So you deploy your containers on Azure Container Apps. Behind the scene, there is a Kubernetes doing all the magic for you, but you don't actually see it, and you can't even customize it. So you don't see the underlying VMs or orchestrators or all the infrastructure. Even the network is simplified, which is very nice. And then it can auto scale, and I'm going to show you a demo. The orchestrator notices if you need more instances or not. So Azure Container Apps can scale up and down your containers just by looking at what's happening in the in the system. It's built on open source stack such as Kubernetes, as I mentioned, but also Kira, Kubernetes even driven auto-scaling. So that's all the auto-scaling magic, Dapper and Envoy. So that's, Azure Container Apps. So how did we deploy the application? We actually used Azure CLI. So we have this command that goes az container app create. And then, so I'm giving the simplest example where we deploy the UI. And in Azure, you always start with a resource group. But then you give all your microservices the same container app environment. And that's very important because all the microservices will run in the same environment. They will share the same network, so you don't have to configure it. So that's nice. All our microservices were deployed in the same environment. You give it an image. Remember that the idea is to deploy a Docker image that is published out there. In our case, it's deployed under Quay. So it's not even Docker Hub or the Azure registry. It just, it could be even your own, of course. You give it a name, it's microservices. You said that this app should be used by the outside world. And what's important is we are deploying this Docker container, but in this case, we need to configure it. In our case, we need to give it the URL of the fight microservice. Remember that the fight is the entry point. So with --m var, you can configure your container. And a more complex example is the fight. So we use Azure Container App, a resource group, same environment, a different image, and so on. And then we configure Kafka. So in our case, it's the Azure Event Hub URL. We also configure, the MongoDB connection string. So in our case, it's Azure Cosmo DB. And because fight talks to hero and villain, we give it the URL. And I'm gonna come back to the demo because I was telling you that Azure Container Apps automatically scales up and down. So here, if I click New Fight, and we wait for a couple of seconds, I should have a fallback. Yeah. What happens is I made a request. Azure Container Apps, in the meantime, while we were talking, scaled down to 0. So I didn't have my microservices. And now if I click again, they are back because, Azure Container Apps has scaled to 1. End of my demo. I stop sharing my screen. Eric, all yours.
Yep. What's interesting with that is when we were rehearsing yesterday, we actually couldn't get it to fall back because the apps the native images are scaling up so fast. If someone wants to go and look through the code, it shows off all the fault tolerance that's built into Quarkus, and it has like a timeout that if it doesn't get a response within a certain period of time, it'll respond with some default data, and we actually couldn't get it to do that. So I was like just trying to decide whether it was a good thing or a bad thing if we couldn't make our app blow up. But I guess it's a good thing. So let's for just very fast, we're going to talk about let's make a very, very fast enhancement. So rather than just simply debugging it in an environment, what if we, now that our application is wired and it's live in a, I'm going to use air quotes here, a real environment, let's do some rapid development and prototyping. Definitely not something you're ever going to do in production, right? But if I want to be able to iterate, and I don't want to have to stand up all these different services on my machine, what if we could do some little proof of concept and then we commit our code and it goes through our CI/CD pipelines and all that good stuff that others have talked about? So what if we decided, hey, how does the fight algorithm really work? What if we did the battle 5 times each time you click the button? What would the result be the same all 5 times? So what I'm actually going to do is I'm going to come over to my code and I'm going to run Quarkus in what's called its remote dev mode. So it doesn't really matter whether the app's running in a container, on a VM. It doesn't matter as long as it's just some remote environment. My local ID, and it's not a plugin with the ID, it's part of Quarkus core itself. I can instruct it to the Maven or Gradle plugins to connect to that remote instance, and it's now synchronized through a WebSocket to whatever it is. So as I start making changes here, it'll synchronize the remote instance. And so what I'm going to do is I'm just going to make a change to the method that handles the fight, and instead of just doing it once, I'm going to do it 5 times. And this is a reactive application, so I need to do it in a reactive way. So I'm going to say create by repeating, and then the work is going to be the.
So here, Eric, you are updating code live in production.
I'm updating live in production, right?
How cool is that?
And I can't change the method signature because then I'd have to go change the UI to receive all the updates. Right, so I'm only going to return the last one to the UI, but as soon as I save that and I come back over, and if I refresh my page here, it's synchronizing over, and we'll pray to the demo gods. Yep, so it just sent. So now I've got my app up here, and if I click fight, you notice over here I've got 69 battles, and if I do new fighters, I click the button again, now I've got 72, so it's going up by 5 each time. And if I refresh this page, you can see, the last 2 times I did it, it actually did it 5 times. So I didn't build a container.
5 messages.
Yeah, it's sending 5 messages. Okay. It's storing 5 records in Mongo, sending 5 messages over. I didn't build a container image. I didn't push it to a registry. I didn't deploy it. It's direct live from my local machine up to the running instance.
Love it.
That's pretty cool. All right, so we're getting close to the end of time here, so we'll leave you with just a few additional resources for those who are looking for more information. As we talked about at the beginning, I've written a book, and it was actually Eric Kostlow, who was here before us, actually did a review on Fuji of this book, back, I think it was late last year, early this year. So it was nice to meet him, quasi in person or virtually. But I wrote a book. I've been active in the Spring community for a long time. I've been doing Spring for a really long time, for dating back to like 2010, 2011. So when I started learning Quarkus, I was like, when you learn something new, you're always comparing it to things you already know, and you're always saying, well, I did it this way with this thing that I know. How is it the same, or how is it different? And so that's why I actually took all of last year, or most of last year, and wrote this book that looks at different patterns and conventions from Spring, and how would you do it in Quarkus, and then what are the differences and what are the similarities. And I focus a lot on testing, because you find like a lot of like the quick start guides and how-tos and whatnot, they talk about how to do something, but they don't necessarily talk about how would you test that thing that you just built, which I'm a huge fan of test-driven development. So I always focus on how would I test the thing, because if I can't test it, I'm not going to build it, right? So that's a free book for anybody who wants to download that. And I think you've got a few as well.
Yeah, I've got a couple of books also free. They are on the Red Hat portal. One is Understanding Quarkus. So really it goes topic by topic, how to do injection, how do I access a database, how do I expose REST APIs. And then you have a practicing Quarkus book where you start from a blank page and you create an entire microservice architecture. So start with my Understanding Quarkus book, then practicing, then Eric, and then switch to Spring, and then come back to Quarkus, something like that.
All right, and just a few references for those, some of the links, the GitHub repo for the superheroes that has all the services that we talked about. There's a guide for if you want to actually deploy it on Azure Container Apps. There's a guide there, and I'm a huge fan of the easy button. I don't like to copy paste. I just want to type a command and have it done. So we built a simple script. It's got lots of command line options to customize how it works. I think there's a workshop as well, and I think that was actually where this superhero sample application came from originally. It was, came from something that you had built a while back.
Yeah, I created that 2.5 years ago. Quarkus was brand new. So I created this workshop and with other Red Hatters, and we played it at several conferences, and got his momentum, and then it was turned into a sample. So today you can still find the workshop, and you can do it by yourself, and you have the sample application. Though that's why we are showing you the 2 repos.
Yep. And then there's a blog that just kind of introduces, if you're more interested in how are the services built, what they do, what their conventions are, that goes into a lot more detail about the actual services. And that's about it. So, hey, it's been great working with you, Antonio, and thanks a lot for working on this.
Yeah, thanks, Eric, for the remote dev that I didn't know of.
All right. Thank you, folks. This was exciting. Thanks for the live demo. Always good to see live demos being presented live on the internet, and they work.
Yeah, you should have seen me 10 minutes into at the end of Eric's talk, because my Azure environment crashed and I had to redeploy everything like 10 minutes before I started.